Security controls only matter if you can prove they work. In this topic, we'll see how monitoring, audit trails, and validation turn an AI architecture from trusted by design into something observable, accountable, and ready for audit. So far, we've designed controls across identity, applications, data, cloud, workloads, and access. Now we shift from design to proof. Logging, monitoring, audit, detection, and validation show whether those controls are actually working in production. Monitoring is the assurance layer that turns AI security intent into evidence. It tells teams what is happening now and whether that activity looks expected. Auditability preserves the trail. Who acted, what data or model was used, which policy applied, and what result followed. Control validation then proves protections work in real operations and simulated attacks. For AI, that evidence must cover prompts, model calls, tools, retrievals, data, and outputs, not just infrastructure logs. Think of AI security logging as a pipeline, not a set of isolated files. Events come from identity systems, APIs, gateways, orchestration layers, vector stores, cloud services, and admin tools. Collection is only the first step. Each event needs shared fields, such as actor, action, resource, model ID, policy, session, and time, so activity can be correlated across components. From there, logs must be encrypted, access controlled, retained, and tamper-resistant before feeding SEM, SOAR, data lakes, or cloud monitoring. Identity logging answers a basic audit question. Who tried to do what, and was it allowed? Capture sign-ins, MFA, federation, service accounts, token issuance, refreshes, and failed attempts. Also record authorization context, the policy evaluated, the attributes used, and the entitlement granted or denied. Administrative actions need equal scrutiny, especially role changes, policy edits, secret access, deployment approvals, and temporary privilege elevation. Correlation IDs connect these events to application, data, infrastructure, and model activity. Traditional monitoring misses important AI-specific behavior. Security logging should follow the request across its full path. Prompt submission, risk and policy checks, model invocation, tool use, agent action, and final response metadata. For each event, capture who initiated it, what system or model was used, configuration details, token usage, latency, authorization decisions, and outcomes. Be careful with content, though. Store sensitive prompts or outputs only when necessary, using redaction, hashing, or protected evidence storage. In a RAG system, the audit trail starts before retrieval. Log who asked, the query or embedding reference, the tenant, source, index, and filters applied. Then capture what came back. Document IDs, labels, relevant scores, and the access decision from the policy engine. Also, monitor vector database changes, including indexing, embedding updates, exports, deletes, and permission edits. The goal is traceability from prompt to retrieved context to response, without copying sensitive content into logs. A strong AI audit trail should let you replay the entire transaction, not just inspect the final answer. Start with the authenticated user and session. Then connect the prompt, policy checks, retrieve data, model version, tool calls, generated output, and any downstream action. The key is correlation. Request IDs, trace IDs, conversation IDs, and agent IDs tie distributed logs together. That complete chain supports investigations, compliance reviews, disputes, and root cause analysis. Audit evidence should support investigations without creating a new privacy problem. Log only what is needed: metadata, redacted values, hashes, or tokens instead of raw sensitive data. Apply retention rules tied to regulation, business risk, and response needs. Protect what remains with encryption, append-only storage, integrity checks, and restricted access. Finally, separate operator, analyst, auditor, and administrator duties so no one person can quietly alter the evidence. Security monitoring starts with raw telemetry, but logs are rarely actionable on their own. First, enrich each event with identity, device posture, data sensitivity, location, business context, and asset criticality. Then combine signature rules for known threats with analytics that spot unusual access, token use, retrieval, or tool behavior. Prioritization separates noise from high-confidence risk. Those alerts flow into response workflows for triage, investigation, containment, and evidence collection. Metrics like MTTD, MTTR, false positives, and coverage help tune the pipeline. AI monitoring has to look beyond normal application errors. Watch the full interaction chain: what the user asks, how often they retry, how many tokens they consume, and what the model returns. A single unusual prompt may be harmless, but override language, encoded instructions, rising token spikes, and unsafe outputs together create a stronger abuse signal. The best detections correlate these patterns with user, device, app, entitlement, model, and data context, then trigger proportional responses. Consider a support chatbot that normally answers billing questions. Suddenly, it queries HR policies, then payroll records across multiple tenants. The retrievals are denied, but the pattern still matters. Minutes later, it tries to call an export tool at 2:15 a.m. Combining role, data sensitivity, action type, and history turns these separate signals into one high-confidence abuse alert. Privilege escalation monitoring makes powerful actions visible, time-bound, and reviewable. Track just-in-time access from request to approval to session start, commands run, and session end. Treat break glass use, off-hours changes, failed elevation, and direct production edits as high-signal events. Watch for changes to guardrails, model routing, RAG filters, vector permissions, API gateways, IAM, and secrets. For the riskiest sessions, keep command logs, admin API traces, or recordings. Monitoring tells you when something happened. Validation tells you whether the control would actually stop it. Treat every AI safeguard as a testable claim. The right user gets access, the wrong agent is blocked, prompt attacks fail, retrieval respects tenant and document rules, and secrets or privileged actions cannot be bypassed. Then automate the loop. Define the control, create positive and negative tests, run them continuously, capture evidence, fix failures, and retest until the control proves itself. Secure AI does not end at design. It has to be observable, traceable, and testable in operation. Capture the right logs, reconstruct decisions end-to-end, detect misuse early, and validate controls continuously. Next, you'll bring these layers together in a capstone secure AI reference architecture.